Welcome to this eLearn Security video lesson on Network Security Post-Exploitation DLL Hijacking. In this video, we're going to cover a combination of tools we can utilize to help us understand the class of vulnerabilities known as DLL hijacking and how we can also identify and exploit vulnerable applications. As we learned in the DLL hijacking section of the course, there are some things we should be on the lookout for in regards to identifying applications that are vulnerable to DLL hijacking. In particular, the DLL search order. The DLL search order is the order of directory paths that an application will look for as it is launched, as it looks for DLLs to import for its functionality. As we covered, these paths are typically searched for in the following order. Sometimes, these paths are writable by administrative level users, and other times, by standard users. Depending on which is the case will provide us with different results. It should be noted that in this instance, we're operating as a local administrator of the target system, which is a prerequisite in this case, with this particular example of DLL hijacking. In order to identify programs vulnerable to DLL hijacking, we're going to use the Process Monitor tool, available from the sysinternal suite. You can download the sysinternal suite at the link below. Another tool we're going to use, also part of the sysinternal suite, is Process Explorer, both of which we already have on our Windows 7 target system here. One of the first things we should do in order to find a suitable application is to take a look at the current processes on the system. Process Explorer offers us a great deal of information in regards to running processes, so we'll use that tool for this demonstration, and furthermore, we'll launch it as the administrator user. When we first launch the program, we'll want to make a minor modification to its current view. We'll add a new column for user from the columns area. You can simply right-click in the columns area and click on the Select Columns option. This will open up another dialog box with some options. For our purposes, let's select the username option, then click on the OK button to apply our selection. We can see we have a new username column. This information will help us in identifying a privileged process we can test for DLL hijacking. As we scroll through the current processes on the system, we can see a good number of them are running as the NT Authority System user. We'll target one of these first. What we're looking for here are third-party applications or processes that are running as system, and our objective is to identify issues regarding the way these applications are loading DLLs upon startup. For this demonstration, we're going to investigate the regservice.exe process. This process is part of the Intel ProSet wireless package, which comes standard on many machines and helps the user to configure wireless settings for their machines. We can see the regservice.exe process is running as system as well. Let's dig into this process a bit further. We can double-click on a process in question and view a number of its attributes. Let's check out the attributes for the regservice.exe process. The first thing we'll want to identify is the location of the binary. We can see here in the Image tab the path of the executable. We can also click on the Explore button, which will open up an Explorer window into this directory as well. We'll just make a mental note of this location for the time being. We can also see that the process is associated to a specific service. We can use the Services tab, and we can see the regservice.exe process belongs to a service. We'll make note of that as well. Now that we've identified a service we're going to investigate, let's next move into the Process Monitor tool. When we first launch Process Monitor, we'll see it already starts to monitor the system, showing us all registry key accesses, threads being created, images being loaded, and provides us with a great deal of situational awareness in regards to what the operating system is doing in real time. The first thing we'll want to do is apply a filter. We can use the Ctrl-L shortcut key, or click on the small filter button in the menu bar at the top of the application. The Process Monitor filter will allow us to specify exactly what it is we want to filter, and for a specific process. As you can see, there are a number of different columns we can filter on, and furthermore, we can refine our filter by selecting from these list of conditions. In our case, since we identified a third-party service using Process Explorer, specifically the regservice.exe process, we'll first create a filter where process name is regservice.exe. This will immediately reduce the noise in our display. We choose process name from the drop-down, leave the condition at the is operator, add the name of the service we're investigating, and then click on the Add button to add our filter, and then OK. Now, since we identified with Process Explorer that the regservice.exe executable is launched by a service, let's open up the Services applet and find the associated service. We can see 3 different Intel ProSet wireless related services here. The registry service sounds like the one we might be looking for. If we open that up, we can see that in fact, it is the service responsible for launching the process we're investigating, the regservice.exe process. And just to confirm, we can see the service is configured to launch at the local system account, as can be seen in the Logon tab. Next, now that we're filtering in Process Monitor for the regservice.exe process, let's stop and then restart the service and have a look at the Process Monitor while the service stops and starts up again. We can already see Process Monitor has generated a real-time view of all the actions created by the process as we stopped and restarted it. We'll click on the Stop Capture button for now and examine some of this information. Now, as we scroll through this Process Monitor output, we can see that when we start or stop the service, that many DLLs are being loaded. We can see this with the load image operation, and we can also see many that are being created with the create file operation as well. We'll want to focus on these 2 operations for our purposes. Another important thing we'll want to look for is under the result column, specifically any items with the result of name not found, which can be seen with the reference to the cryptbase.dll file here. So, to summarize, we configured a filter in Process Monitor for the regservice.exe process we identified belonging to third-party software installed on the system, started the regservice.exe service, and Process Monitor is now giving us a real-time view of all registry key access. And importantly for now, all of the DLLs the process is looking for, and in which directories it is looking for them. Now, we can see that the process is first trying a create file operation for a cryptbase.dll file with the /program files /common files /intel /wireless common /directory. In this case, we can see we get a name not found result, and it then moves on to look for the cryptbase.dll file in the /windows /system32 directory. At which point, it loads it, since it is there. This is the search order that the executable is taking, as it's looking for DLLs to import. Seeing as it's checking the /program files /common files /intel /wireless common directory first, and not finding the DLL in that location, this is a perfect opportunity to put our own cryptbase.dll file in the wireless common directory. When the service starts, it will follow that search order, find our DLL, and load it, instead of the DLL in the system32 directory. Let's put this to the test. We've created an interpreter _HTTPS payload using MSF Venom. That will call back to our attacker system with the following command line. We're calling it payload64.dll, as seen here on the target desktop. On the right side of the screen here is our attacker system running an instance of Metasploit. Let's set up our multi-handler first. Next, we can simply copy our payload64.dll to the wireless common directory and rename it to cryptbase.dll, the DLL which the process is looking for upon startup. Next, let's see what happens when we stop and start the redservice.exe service. After a few seconds, we can see we've received an interpreter session from our rogue DLL file. Interacting with our session and running the getuid command, we can see we are system, and we can further confirm by dropping into a shell and running the whoami command as well. Something to note about this particular DLL hijack is that since it is a system service that runs at system boot time, we will have an interpreter shell whenever the system is rebooted, a great way to maintain system-level persistence to a target. And if we go back to Process Explorer, we can see that redservice.exe process has spawned a run DLL32 child process and is running as system. And we can see that the run DLL32 process is now the process responsible for the connection back to our target system. And this concludes our video lesson on network security, post-exploitation, DLL hijacking. Thank you for joining us.